Hi everyone. In this video, we are going to do questions on exponents with respect to variables. Means you can see on my screen that all the questions that we will be doing are with respect to variables having some powers, that is exponents, right? So these are 4 questions that we will be simplifying in the video, and then there will be 3 questions where we will be proving. So do watch the video properly till the end so that you can learn them how to practice, because guys, trust me, these questions are highly important. They will be coming in your school exams once or the other, and you will also get them in your school assignments. Okay, so let's quickly start with them. Now, starting with the first question, it's a pretty easy one. What we have, a square root of x cube and y to the power minus 2. Now, what we need to do, we need to actually separate them. That is, first we will convert the square root in a radical form such that it will become x cube y to the power minus 2 whole having a power of half. That is a square root, right? Now, I will allocate this power of half to each of the independent variable, right? So what we will have, x cube half and y to the power minus 2 half outside, right? This is what we get. Now, just the last step, x to the power 3 by 2. What I did, I multiplied the powers. A to the power m, outside n, the powers get multiplied, right? Into y to the power minus 2 by 2. So now over here, 2 and 2 are getting cancelled. What are we left with? X to the power 3 by 2 into y to the power minus 1. Now y is having minus 1. So I will take that down because we need to convert the negative power into positive. And here is our final answer for this question. What we did, we just converted the square root first in the radical form and then the law a to the power m outside n, and we kept on multiplying the powers. In the end, I converted the negative power and brought it to reciprocal. Okay. Now, let's move on to the next one. Here what we have, now the power over here is in a rational form. X to the power negative 2 by 3, y to the power negative half, and outside we have a square. Okay, so let's start doing this. X to the power minus 2 by 3 into 2, y to the power minus half into 2, right? Now, this 2 and 2 gets cancelled. So what we are left with? X to the power minus 4 by 3, y to the power minus 1. Now what I can see, both my x and y have a negative power. So what I'm going to do, I'm just going to bring them down and they will retain their original powers. So x will retain 4 by 3 along with y. And this is your final answer. I understand these questions are not giving any satisfactory, in the sense, a satisfying answer, but that's it. We can't do anything more simplification over here. This is going to be the end of this question. Okay. Now, next one again, it's a pretty easy one. What we have, x to the power minus 4, y to the power minus 10. And outside, now we have another rational power over here, which is 5 by 4. So how do we do it? Again, we are going to multiply the outside power with the inner powers, right? So x to the power minus 4 into 5 by 4 over y to the power minus 10 into 5 by 4. This is what we are doing. Now, 4 and 4 got cancelled. So, in denominator, we have 10 and 4. They will also get reduced by 2. So, this becomes 2 and this is 5, right? So, what I am getting? I am getting x to the power minus 5 over y to the power minus 25 by 2. Because what we were having a negative 5 here, a 5 here over 2, right? So that is why it became minus 25 by 2. Now, what are we getting over here? We can see both x and y have negative powers, but x is in the numerator, y is in the denominator. So I'm just going to shuffle them, in the sense I will bring x down and y up. such that their powers become positive. So now we will be left with y to the power 25 by 2 because I have brought it up and taking x down. So x to the power 5. That's all. We can't simplify it further and we will leave the answer at this stage. Okay. Next. Okay. Now in this one, we have got 4 terms, right? And each variable x have a with power L, x power n. And outside also they have got a power which is 1 by ln. You have to do this question carefully. And these kind of questions in itself actually come for 3 marker. Because there are few steps which you need to do carefully. So let's start doing them. First of all, what I'm going to do, I am going to subtract the powers over here. Okay. X to the power. Okay, I'm not going to subtract, but I'm going to actually multiply the powers, that is L with LM, M with LM, right? So let's see how do I do it. L into 1 by LM over x to the power M into 1 by LM. Okay. Now, I will put this in bracket. Then the second part, x to the power M into 1 by Mn. The same kind of step is going to repeat in all the 3 brackets. X to the power n into 1 by Mn. X to the power n into 1 by Nn. Last, x to the power L into 1 by Nn. Right? Now what can we see? We can see in the powers there is a cancellation. LL got cancelled. M got cancelled over here. M cancelled here. N cancelled here. Then N cancelled here. L cancelled here. Right? What are we left with? We are left with x to the power 1 by n over x to the power 1 by L into x to the power 1 by n over x to the power 1 by m. Then x to the power 1 by l over x to the power 1 by n. Now the question is actually very easy. The previous step was the main step where you had to do it carefully. Okay. Now if you see, we have got x to the power 1 by m, one on top and the other at bottom. So they got cancelled. X to the power 1 by n and x to the power 1 by n also got cancelled. And the last, x to the power 1 by l and x to the power 1 by l also got cancelled. Now everything is cancelled. We are just left with 1 over here, right? If you want to do, there can be another kind of a step instead of cancellation, because in some schools, teachers impose that this step also needs to be done using exponential laws. So what you could have done over here, I'm just writing in the bracket underneath. We can do x to the power 1 by m minus 1 by m. I am kind of collecting this and this, right? Then in another bracket, x to the power 1 by n minus 1 by n. And the last, x to the power 1 by l minus 1 by l. Okay, so now in all the brackets, we are getting x to the power 0 into x to the power 0 into x to the power 0. And we know anything raised to the power 0 is always 1. So our answer is again 1. That means whether you do this way or whether you do this way, the answer is going to be 1. Okay. This is a highly important question. Do practice it carefully. Now, we are on to the proving questions. We are done with simplification questions. And now we are on to the first proving question, where we have a to the power negative 1, a to the power negative 1 plus b to the power negative 1, a to the power negative 1 over a to the power negative 1 minus b to the power negative 1. Okay. And what we are supposed to prove, on the right side, we have 2b square over b square minus a square. So let's start doing this. Okay. First of all the terms that we have on the left having a power of negative 1. And how do we write them? We will be using 1 over a form. Okay. What I did, I just converted the negative power and brought a to the reciprocal. And similarly, I will be doing with the rest of the terms also. So we have 1 over a plus 1 over b. This was my first, and I am putting a bracket. Quotient didn't have the bracket, but I am putting it because it makes it separate and it is easier for you to operate also. Then the next row, 1 by a again over 1 by a minus 1 by b. This is what we get. I am just keep writing left hand side. We are supposed to prove equal to the right hand side. So I'm just working on the LHS. Now, what do we need to do next? In the denominators, we have 1 over a plus 1 over b. And the second denominator is 1 over a minus 1 over b. We are going to simplify these respective denominators by taking the LCM in their own and stuff. Okay, so let's start. We have 1 over a, the numerator remains as it is. Whereas in the denominator, when you have 1 over a plus 1 over b, what will you do? You will take up the LCM, which will be ab, and they will get cross multiplied, right? So that means we will have b plus a, right? I am going to write that only over here, b plus a whole over ab. So this is our first bracket, right? And similarly, we will be writing the second bracket. 1 over a on top remains as it is. Taking the LCM in the denominator and cross multiplying leaves me with b minus a over ab. Okay, now what to do next? Guys, we have a fraction over fraction. Now what I'm going to do over here, do pay attention carefully. I'm just writing something. If we have got a over b whole over c by d. Now what does this mean? This means I am having a over b divided with c over d, right? So how do we solve this? Because this is the stage where many students get confused that how we are going to simplify it. So I'm just telling you what is the concept behind it, that how do I am going to actually move on with the next step. This is, we are getting a by b divided with c by d. That means the first fraction remains as it is. Division gets converted into multiplication, and we are going to flip the second fraction, that is, we are going to reciprocal that, d over c. So that means if we have a fraction over fraction, it eventually needs to be converted to a by b into d by c. मतलब जो denominator में c by d है वो उल्टा हो जाए. Okay, and that is what I'm going to do over here. So pay attention now. It is going to be 1 by a over a 1 by a over, no, it is not going to be 1 by a like that. 1 by a into ab over a plus b. This is what we get. What I did, I just reciprocaled the denominator fraction. A by b was my ab was my denominator. I brought this ab on top. Okay. Now similarly, I'm going to operate on in the second fraction. 1 by a into ab over b minus a. I hope this step is clear because this was very important to understand. Now a and a got cancelled. A and a got cancelled here also. What are we left? I am left with b over a plus b plus b over b minus a. Right? This is a plus b and b minus a. This is what we are left. We are left with just two fractions now. Again, we are supposed to take LCM. The denominators are different. We are going to multiply b into b minus a plus b into a plus b. In denominator, we have, I'm writing a plus b now as b plus a into b minus a. Why do I do that? Think quickly. So that I can apply the identity of x square minus y square in denominator, right? And let's expand the numerator. We have b square minus ba plus ba plus b square. So ba got cancelled. In denominator, we are having b square minus a square. Now, what are we left with? B square plus b square, and hence that gives me 2b square over b square minus a square. Hence, proved. Let's just see. This was the expression they had asked, right? So we are done. And at the end, do not forget to write hence proved, because it was a proving question. It is necessary to conclude in wherever you are being asked, show that or prove that. It is necessary to write at the end hence proved. Okay. Now, the second question of the proving. This question says 1 over 1 plus x to the power a minus b. Then the second fraction 1 over 1 plus x to the power b minus a. Okay, now we can see we have only single variable x base, right? And having some powers as a minus b and b minus a. So we are going to simplify that. How do we do it? Let's see. 1 over 1 plus x to the power a over x to the power b. This is what we get, plus 1 over 1 plus x to the power b over x to the power a. This is what we are having. Now, again, I am going to take LCM in the respective denominators. Okay. So, keeping the top one as it is, and when I'm going to take the LCM, it also had 1. So, it will get multiplied with xb, that is x to the power b plus x to the power a whole over x to the power b, plus 1 over x to the power a plus x to the power b over x to the power a. This is what we are getting. Now, what we have, what kind of a form is it? It is also the kind of form as we learned in the previous example, previous question, a by b over c by d. But over here you will say that, ma'am, we do not have a fraction on top. Yes, we just have a single number, but we can consider that as 1 over 1, right? So now I can say that we have a fraction of a fraction. So we are going to do that thing again. I am going to write the top one as it is into this denominator goes on top. So it becomes like this, over x to the power b plus x to the power a, plus same process 1 into x to the power a over x to the power a plus x to the power b. This is what we got. Now, what we are left with? xb over xb plus xa. I am writing each and every step in detail. I am not doing any shortcuts so that you understand it properly. And guys, these steps are actually important. Do not try to act smart by thinking that yes, you know you can do it. Because if you miss out one step in your confidence or overconfidence actually, and you do not get the answer, you will have to redo the whole question again, and it will prove to be a costly affair because you will waste time. Okay. So then same denominator xa plus xb. Now what can we see over here? I can see that we have same denominators. The only difference is in the first term we have xb plus xa, in the second we have xa plus xb, but eventually they are same terms, right? That means we can just add the numerators as it is. So adding the numerators gives me xb plus xa, whereas in the denominator we had xa plus xb, right? Now what is this? They're absolutely same, right? I'll just cancel them, strike out. What are we left with? 1. And that is what we were supposed to prove. Question was pretty easy to be done. The only thing is you should know that where to start and how to do it carefully. Okay. And yes, at the end, we need to write hence proved. Okay. Let's start doing the last question. This is 2 to the power x minus 1 plus 2 to the power x whole over 2 to the power x plus 1 minus 2 to the power x equals 3 by 2. Okay. Now, what we can see that we have all the bases of 2 on the left and we are supposed to prove equal with 3 by 2. So let's see how to do this question. The first 2 has a power of x minus 1. So I am going to write it as 2 to the power x over 2 to the power 1 plus 2 to the power x. It remains as it is. Now, the denominator. The power is x plus 1. That means the bases are supposed to multiply. Okay? It comes out like this, right? Now, what needs to be done? If you pay attention, we have 2 to the power x, 2 to the power x as common factor, right? Over here also. So I am going to take that out. It leaves me with 2 to the power x outside and inside 1 by 2 plus 1. Because I took out this 2 to the power x, there was nothing left. So just do not commit a mistake by writing this as 0. When you take out something common and you do not see anything left, it is always 1. This is kind of a factorization we are doing. Okay. So now in denominator also, I will take out 2 to the power x out. What I am left is 2 minus 1. Okay. Now easily we can cancel them. 2 to the power x, 2 to the power x got cancelled. What are we left in the brackets? On top, 1 by 2 plus 1. I'm going to take the LCM. So 1 by 2 by 2. And in denominator, 2 minus 1 is 1. So what can we see? We have just achieved the final answer. 1 plus 2, 3 over 2. And that's it. We got a final answer, which is 3 by 2 in just 2 steps, right? At the end, do not forget hence proved. So in this video, we dealt with so many questions with respect to exponents and variables. That is, variables were in the base and the numbers were the powers. After that, we saw where the numbers were the bases and the variables were the powers. So we dealt with all the questions, whether it was simplification or proving. I hope you learned everything. So happy learning.